right, thank you. So what I want to talk about today is the architecture that we're seeing emerge around cloud native and how at every kind of level of this architecture, we're designing for various options for users and customers to plug in into their infrastructure, into their existing infrastructure, or maybe perhaps making new infrastructure choices. So first I want to introduce CoreOS and what we're doing. CoreOS is a company with a mission of securing the internet. This mission is not something that we'll accomplish tomorrow or in the next year or two. It's more of a SpaceX style, we're going to go to Mars sort of thing. And we're currently in low Earth orbit. And the architecture that we're going to be describing here is the first step that we feel towards achieving this mission. And there's a few strategies in this whole cloud native thing that we feel are important in order to accomplish this mission. The first is the separation between applications and the operating system. Of course, everyone who is interested in the term cloud native has already heard of containers, and this is what the mechanism that allows us to do this. It's about making servers really, really consistent so that when I deploy an app to a server and I take it back off, or I deploy two apps next to each other, those apps operate the same and can be removed without any trouble. And then hopefully through that consistency, we're able to actually improve the way that we do upgrades and manage the deployments of our servers to the end that we finally are able to simplify the management and overall way that we deploy applications into the infrastructure. And the goal here is that we're not trying to create a platform that only runs behind the firewall or inside of some cloud environment where all these fancy APIs already exist, but to do it on top of any infrastructure. And so that's our mission and kind of what plays into this architecture and the things that we're thinking about in this architecture, these major strategy points. And so the first thing I want to talk about is really how we see people thinking about cloud native and roughing out the edges of what cloud native means. And there's really three major components that we think about. The first is application packaging. The second is Linux at scale, or operating systems, virtual machines, and physical gear at scale in order to support these applications. And the final is clustering, which allows us to mitigate the potential uptime risks to create systems that are able to achieve density and are easy to manage through APIs. So the first is about application packaging, and it's about consistency. And we win here because of this abstraction. This is something that we've never really had in the past. In the past, our Linux distributions have tightly coupled the idea of the application to the OS, which is a bit of a problem because it means that people don't actually end up upgrading their systems. And so what we've done with containers over the last few years is that we've opened up this opportunity for building smaller Linux operating systems that have smaller pieces and less components to actually worry about, which means that you have the opportunity to not only reduce the footprint, the potential attack surface area, but then also, because of this abstraction, potentially upgrade them over time. And so the first kind of plug-in interface that can be achieved here in this whole cloud native space is through a shared image format. So we have this idea of a container, this container that you can consistently pull down between any host and run. And in order for that to be successful, we need to have an entire ecosystem of tools that can package and build these containers, tools that can host and upload and download these containers, and hopefully verify those containers once they are landing on a machine, and really run those on top of any container engine that's available. And this is work that's going on today inside of the Open Container Initiative. There's currently draft specifications for the OCI image spec, and we're hoping to get the image spec wrapped up into a 1.0 over the next few weeks and months. Next piece is Linux at scale, and really this is a plugin of a sort as well, a place that people can make their infrastructure choice and still be able to adopt this style of infrastructure. Because the requirements have shrunk down so much of what the Linux operating system is, we've kind of seen this explosion of container-focused operating systems. Obviously, I'm particularly partial to our first product, which is CoreOS Linux, but this style of infrastructure means that people are able to take their exact same application as long as it's consuming the Linux ABI, and they're able to move it around. And they're able to kind of make that infrastructure choice for themselves, either late or early as they're making decisions about what they want their sort of cloud-native infrastructure to look like. And it's all, again, we're able to do this because of this abstraction layer. And the Linux operating system starts to shrink in its responsibilities and comes down to the point of really just focusing on, over the next few years, just a container engine that's able to take one of these open container image specs and download it and execute it, and then the Linux kernel and some ancillary other systems like management system through SSH, and then a PID1, which today is inevitably systemd. And the advantage and the thing that choosing a Linux operating system and building this on top of Linux gives us is the advantage that Linux has had, and the reason that it's had such wild success over the last 25 years is that Linux is in a spot where it runs on top of any infrastructure. So people can confidently use pretty much any particular Linux distro today and ensure that it runs on top of their cloud platform of choice, or inside of the virtualization platform of choice, or inside of their bare metal environments. So the next piece is clustering, and this is about enabling people to have a way of managing their applications over time, their cloud-native applications over time, and then removing this risk of uptime. So really what we want to end up in is this world where you have a bunch of machines, you have your key performance indicator, which is, hey, I have X number of requests per second I want to be handling, and whether the application is healthy or not. So you are able to add more servers, and you get more capacity as those servers spin up the container that's running your application. And then similarly, if the server dies, you lose some capacity, but the application remains healthy. And hopefully what we'll also get out of this is the ability to upgrade and move from, say, one version of the container to the next while keeping the application, the overall health of the application, and the overall customer experience in good shape. So you're able to, say, talk to an API, say, hey, I want to remove this copy of the container, spin up this other copy, upgrade the system over time, and hopefully, once you're confident that it's operating correctly, get a fully healthy system. And in the CNCF and for CoreOS, the technology that we are relying on in order to be able to do this sort of clustering system, have these APIs to manage this, is Kubernetes. And we talk about it as sort of an operations paradise. The things that it's promising are the things that operations teams and engineering teams have been pursuing and often pursue when they're thinking about deploying an application. It's the dream that as the business requires more of the application, they're able to easily scale it out without having to redesign or replan the infrastructure that they built for it. Being able to deploy new code when they find out inevitably that there's a security vulnerability in some package that they've chosen, or being able to fix bugs as they find, oh shoot, we actually handled timestamps incorrectly, we need to fix the bug in our application so that we're able to make sales again, we're able to run our reports again, et cetera. And then the sort of holy grail has always been, well, I hope that when I deploy this stuff, it will actually tolerate if network operations messes up network configuration, or the power supply goes out in my machine, or the RAM goes bad, et cetera, and I have to RMA it, that the application keeps running, I don't get paged, and I can handle it in the morning. And so there's really not a plugin interface here so much as a shared architecture that we're seeing between all the different options that people are talking about in this cloud-native space. And the architecture is something that's super familiar to most of us. If we've built web application, the architecture almost inevitably looks like this. We have some sort of user on the web browser talking to the API server maybe grabbing additional resources from other machines inside the cluster. There's a primary data store for the thing, and that's it. And I want to think about this architecture and more regularly articulate this architecture as we're talking to users about cloud native. One of the things that I think is a bit of an anti-pattern as we engage with customers and explain this stuff is it's really easy to show every detail of what Kubernetes is doing or Mesos is doing inside of your ecosystem. But really, it's about having an API that the system administrator talks to, talking to some command line tools, and that there's some sort of primary data store that those systems are being backed by. And I think the thing that we can get out of that by having this conversation at a higher level with people is to make it not feel so alien and not so unfamiliar. Still, if I talk to people today, you only get like a quarter or less of the room to raise their hands that they understand what a scheduler is, or they've used a scheduler-based system. And to immediately have the diagram of proxies and network overlays and et cetera is just really overwhelming when really the architecture of cloud native is a pretty straightforward and well understood architecture. Cool. And really the one thing that is just ever so slightly different than a web application is that instead of talking to individual Linux machines, we're telling individual Linux machines what to do in order to service the API requests. Okay. So in our particular architecture inside of CoreOS, instead of it being some abstract cloud native command line tool, we of course use Kubernetes, and etcd is the primary data store when we're talking about this style of architecture. But it holds true for every single other sort of scheduler-based, orchestration-based system that's emerged over the last 5 to 10 years in the open source space. Okay, so those are some high-level things about the value that cloud native actually brings to customers and how you talk about the architecture. But of course, there's things that we talk about in operations and in how actual compute and infrastructure works that are kind of always givens. These things are monitoring, storage, networking, and authentication. And in these 4 categories, we're actually doing a pretty good job too as we develop this style of building infrastructure. The first is kind of export formats around monitoring. So we had this diagram earlier where there's these key performance indicators that you actually care about in your environment, but how are you actually gathering up this data? Most people are going to have, in a lot of environments, they're going to have a very static, traditional, say, Nagios or something like that system. And one of the things that's emerged over the last year or two is the adoption of this cloud native project in the Cloud Native Computing Foundation now called Prometheus. And what Prometheus has done is it's a few things. It's an actual implementation of a monitoring system. So it does monitoring and alerting. It's an actual concrete implementation. It's been working with other projects, in particular Kubernetes, to ensure that not just user applications, but actually the cluster itself is something that can be monitored and operated. And then what that means is that Kubernetes isn't directly integrating with Prometheus. It's not like a direct code import. What it means is that there's some rough consensus between Prometheus and Kubernetes around this export format for important metrics. And then that's a format that anything can consume, not just Prometheus. But in this particular case, Prometheus is used to consume those metrics and exports them as useful time series data to the person operating the cluster. And similarly, for etcd, we've exported metrics that can be consumed by Prometheus so that now your API servers, all the infrastructure around Kubernetes, and the primary data store etcd can be consumed. And what we're hoping to see is that through this sort of rough consensus building around how these export formats work, that the applications themselves that the customers care about starts to export these style of metrics. The community around Prometheus has built adapters to existing export formats. And over time, we hope to see the emergence of sort of standards and norms for applications wanting to be monitored in a cloud-native way. All right, so there's a bunch of other pieces, and this is primarily related to the compute stack. So identity, network, and storage, pretty fundamental to any IT operation that you talk to. And all of these things, to be perfectly frank, we're not going to rip and replace everybody's infrastructure in order to adapt cloud native into it. It's going to be a transition. They're going to have existing solutions for each of these concepts inside of their environment. And what our goal here is inside of Kubernetes and inside of cloud native is to ensure that there's a way for those enterprises to interop and interact with these things. So the first is identity. Inside of Kubernetes, we have introduced a thing based on a standard called OpenID Connect, which is a thing that is extremely poorly named. They've took two brands that are extremely misunderstood, which is OpenID and OAuth 2, and then they slam those two ideas together into yet an even more obscure brand called OpenID Connect. But the technology itself is very sound. It's the thing that is powering identity inside of Salesforce, when you log into Google. It really is the kind of trust fabric of the internet. And so identity with OpenID Connect is something that we brought into Kubernetes, and we're starting to see emerge as well inside of Cloud Foundry and lots of other different projects. And the basic architecture is that there's a relying party, say Kubernetes in this case. There's the actual OpenID Connect protocol, and as long as somebody is compliant with that protocol, Kubernetes can consume it to be able to say, engineer Sally is actually who she says she is, and she's allowed to log into the cluster. And this opens up all sorts of opportunities for ways of leveraging existing identity inside of enterprises. So in the case of CoreOS and our Tectonic product, we implement OIDC, but we are able to back it with LDAP. Or people can take Google applications. Is becoming very, very common for companies. They're able to take their Google applications logins. So foobarexample.com is able to log into a Kubernetes cluster, et cetera, et cetera. I put it on here also. UAA, which is the identity management system inside of Cloud Foundry, is starting to, there's a bunch of patches that have been going in over the last couple of weeks and months to make it a fully compliant OIDC implementation. So we're on a good path here to both bridge the world of existing identity inside of companies and that users expect, and relying on the new world of cloud-based identity all over the internet. The next piece is integration with networking infrastructure. So this is an emerging standard that has been worked on. It was first built as part of the Rocket container engine that we built at CoreOS and introduced as open source about 18 months ago or more. And the idea with the container networking interface is very straightforward. What we're trying to do is inside of a lot of existing network infrastructures, you have this thing. You have one host and then one IP. It's not a very sophisticated network, but that's just the way that the world is. And in this container-based world, a lot of people want to, in order to adapt to existing service discovery mechanisms like DNS, and able to use existing load balancing systems, they want to be able to give an IP to each of their containers. And so this is the problem that we were trying to solve, and we realized there's 1,001 different ways of solving this problem. And so instead of trying to prescribe, this is the one solution in order to get routable IPs between a bunch of containers, what we did was we built this interface called CNI, and we've started to, at this point, the community is pretty vibrant around CNI. We have a bunch of different networking vendors involved. We have a bunch of different folks like Mesos and Cloud Foundry using the thing. Kubernetes obviously uses CNI. Rocket uses CNI. And there's kind of a collection of vendors and options that are emerging around this thing. The great thing about this is that without really having to understand cloud native or engage with every single potential solution around cloud native, the traditional consumers of networking technology and the traditional vendors in networking technology can just target one piece of technology and ensure that that's something that can be readily consumed by lots of different options. And again, like, architecture is pretty straightforward. There's a container networking owner, like Kubernetes. It implements CNI, and then the user, whoever's setting up the system, maybe the network vendor, configures the plugins, and that's pretty much the end of the story. It's a straightforward technology based on really straightforward Linux interfaces. And then this is the name of this is to be determined. This is an in-progress sort of set of discussions that are happening between Kubernetes, inside the Kubernetes community, between a number of different storage projects, et cetera. People are very insistent that we call it CSI. So we've played around with other terms like flex volumes, et cetera, but I'm going to try my best to get CSI as the name. And the idea here is that we have an interface where scheduling systems are able to tell the storage system, my expectations around storage, I need these QoSs, I need it to land inside of this data center, it needs to be in this failure domain, et cetera. And that however those systems care to expose the storage, whether it's at the block level or the file system level at NFS, or maybe it's a cloud provision system like EBS or Google's persistent volumes, that those systems are able to consume it. And again, it's an interface that keeps everyone kind of sane and reducing the dependency graph and that the extremely large matrix of support that people have to worry about when they're wanting to select the storage vendor to put into their cloud native solution. All right, so the big ideas here are that we're trying to create interfaces where people are able to rely on things like the open container image in order to have a standard application packaging system and rely on that standard to interoperate between the way they host and the way they store and the way they eventually run containers. Building these things on top of Linux and shrinking the footprint of Linux so that these sorts of technologies can be ran on any sort of infrastructure that exists, whether that be cloud or bare metal, et cetera. And then introducing the patterns of clustering to the customers without actually overwhelming them about what it means. And there is a very, very clear architecture here that we can talk about that is shared across all of these different systems. So with that, I just wanted to close with what we're actually doing day to day. We have a system called Tectonic, which kind of brings these things together, brings together identity, brings together Kubernetes, brings together CoreOS Linux into a coherent stack. And there's a lot of technologies that are out there today that make all this technology possible. And there are a lot of things that we work on and that we contribute to. What we want to do is kind of simplify and curate that stack for people who are interested in running their infrastructure in this way. So instead of it looking kind of like a sea of open source projects, it looks like a well-understood sort of enterprise stack of software that is a combination of both open source and some of our products like Quay and our identity systems. And similar to that story of being able to run Linux on top of any platform, we want to be able to bring this whole stack of software on top of any platform, utilizing containers, open containers, et cetera, to do that. And we want to always be telling this story of this infrastructure is something that's approachable, it can be deployed, and it can be understood, and it can be operated at scale without huge amounts of learnings and complexity. At the end of the day, what we're talking about here with all of this technology is we're not reinventing the way applications run, we're not reinventing the Linux process model. These are just processes that are executing, network services that are talking to each other. So it's a combination of these three things together as a stack and a platform. So the final question, of course, is like, oh, this all sounds good. Is anyone using this sort of stuff in prod? This is a very, very common story for me. There's a company that, very dynamic, young company, adopting this stuff without talking to anyone. They pick up the instructions on CoreOS.com. They see that it solves a problem that they have. Their problem in particular was that they wanted to on-ramp new developers without having to teach them everything about configuration management, without having to teach them about AWS and the APIs that are involved there. So they just picked up CoreOS Linux, AWS, and Kubernetes. They deployed it on there. They built their custom deployment systems by just consuming the APIs inside of Kubernetes, built a dashboard that integrated with their configuration management system and their source control system, so people would understand where they are in the queue, when their code was going to go out, when they were going to be on call, and it was all automated by the operations team. And they have this all running in production today. And obviously, this is always like harkens back to the old refrain, oh, this stuff is only good for those San Francisco startups that are always just using the latest technology because that's what they read about on the internet that one time. But we also have very large publicly traded companies that are using this sort of technology as well, using containers, adopting CoreOS Linux, these sorts of things. So ISC gave a talk at our conference, Tectonic Summit, a while back, and they were talking about, like, yes, we're a publicly traded options exchange, and we use these sort of technologies because we see the advantages of how using containers to move around our workloads actually provides value. So they're running these things in both AWS and bare metal for low latency, lots of transactions in a production environment. And there's lots of other stories that I could tell about people adopting this style of infrastructure, and they're adopting it readily because they do recognize that there are multiple vendors in the space. Those multiple vendors have APIs and ways to plug in into their existing infrastructures, and then also provide advantages as they're thinking about their infrastructures moving to 3, 5, and 10-year scales. And it's because of the interfaces and the technologies that we're building today that they're able to paint that vision for themselves and paint the vision inside their organization. So CoreOS's mission is to secure the internet. We're doing that with a bunch of strategies around separation of the operating system from the apps, making services consistent, making it easy to upgrade, simplifying application management, and doing it on any infrastructure. I have a couple minutes for questions. You can find all of our docs up there at coreos.com/Kubernetes. There are people every day just happily adopting this technology. And with that, I want to thank you. Thanks.